In this video I will share versions 1, 2 and 3 of a 3D printable camera Lucida that I designed in CAD modeling software. I'll go through the designing process over these iterations, share some 3D printing tips and the subsequent assembly procedures. There are also chapters available in the timeline if you prefer to skip to a specific section. If you don't know what a camera Lucida is, it is simply a tool to aid drawing from life. It works similarly to a autocue or teleprompter in that a reflected image is displayed on a transparent surface which can be aligned, in this case over a piece of paper, to help plot the composition of images, drawings and paintings. The artist, when using the tool, sees a superimposition of both the subject ahead of themselves and the surface being worked on below. There are some great videos, discussions and demonstrations of modern recreations of these old tools that you can see on screen and which I'll link to either in the information card or through my website. There's also a wonderful book published in 2001 and a television documentary from 2002 by David Hockney called Secret Knowledge: Rediscovering the Lost Techniques of the Old Masters. The title is quite suggestive, but in essence the artworks that we so often hold on a pedestal and judge other artistic endeavours by, we even just put ourselves off attempting to make art because of the perceived raw talent and genius needed, were in fact heavily reliant on optics and mirrors and bits of string and a little bit of maths to help compose images with a photographic likeness. Various bits of equipment which predates chemical photography and were a stepping stone towards that invention were being used by artists, scientists and intellectuals working in Florence and the Flanders from the 14th or 15th century onwards. There are a few types of camera lucidas that I've seen, one type using a glass prism and a simpler version with a piece of mirror and clear glass, which is what I'll be recreating. And there is already available a 3D printed version online designed by Chris Borge, but I'd like to make one myself, because through making I think I'll understand the tool and process to use it more thoroughly. Version 1 comprises of a central body piece with grooves, opening and threaded mounting holes. Two side pieces which have indentations for mirrored and clear acrylic pieces, as well as corresponding through holes for mounting. The aforementioned mirrored and clear pieces of acrylic. 8 M3 x 10mm machine screws and 4 M3 locking nuts. The top viewfinder piece. And a second-hand eye cup that I bought from eBay because I thought it looked interesting. I am using acrylic mirror and clear acrylic pieces and not front surface mirror or partially silvered two-way mirrored glass, which supposedly work better when using this contraption in outdoor bright conditions. I'll decide whether to replace these later depending on how successful the acrylic pieces are. And this is a short animation of the parts with titles which you can pause the video to view if necessary. And following that I will share the version 1 assembly process. Now there were some issues with version 1 which prompted me to develop the design, and these included the viewfinder, which while looking retro and cool, in fact had a restricted viewing angle, which you can see better from this photo looking downwards into the viewfinder. Also, I couldn't find a suitable diopter lens to correct for use without my glasses. That's the corresponding sketch where I wasn't wearing glasses. The 3D model screw threads were not located in the best place, and the plastic around one actually cracked. The protrusion for the smartphone clamp needed to be redesigned as well. The tapered angle increased and roundovers added to the end corners. This was needed to increase the grip of the universal Manfrotto phone clamp that I was using. For version 2, I redesigned the viewfinder so I could use it while wearing glasses, because I just have to wear them now, getting old and all that. I made some changes to the main body, including adding a couple more threaded fixing positions, as well as adjusting the threaded mounting location so there was a little bit more space around the openings, which should help prevent splitting. Reinforcing the 3D modelled threads for the M3 x 10mm machine screws, and that has a subsequent knock-on effect because the side pieces are slightly different, like that. So overall it's a slightly different design, should be a little bit more robust and easier to use. I also changed the shape of the tapered grip by increasing the taper angle and chamfering the top and bottom edges, which helped to increase the clamping grip. I had designed a slot at the bottom of the piece for a size A Coquin neutral density filter, which is sometimes needed for outdoor conditions and may help by making the image clearer. But I'm still waiting for that to arrive in the post before I can measure it with my vernier caliper and adjust the size in the 3D model. I could also use the slot for additional attachments like a photo or small object holder, but that is something for a future version. I realised I wanted to send a few of these to some artist friends of mine for them to use and potentially feed back to me their thoughts. And I realised the shape would increase the cost of shipping, so I redesigned the object once again, this time so the main body was split into two sections, one of which rested into a new slot recess. I also finalised the 3D printing process. Here I reinforced the threaded mounting holes by adding a modifier shape within Prusa Slicer in the form of a cylinder, which I specified the size and location. They're just a little larger than the threaded openings, and I could choose to modify the infill density and pattern so they were higher at 90% compared to the rest of the model, which was at 20% infill. The additional material around the hole should further help with the splitting issue I had earlier during version 1. I also did the same around the through holes on the side pieces, which meant there was more material around the opening to help with compression of the plastic by the machine screw heads. And while filming I noticed I had made a mistake and only positioned one half appropriately, so I corrected this. I wasn't sure about printing these parallel to the printer bed, as I think the thread quality and detail is better the other way around, but needs must, so I printed them this way, and after using them it seems to be okay. 3D model threads are not designed for repetitive use, and once this object is assembled, you most likely won't need to disassemble it. here is another animation of the parts which make up version 3, with captions and which you can pause to read if necessary. So this is version 3, which I've designed to be flat pack, be a little bit easier to post because I'd like to send a couple of these out to some friends to try out. The second you hit a little bit of resistance, you just stop. You don't want to thread these too tight because they are going into a 3D printed modelled thread, and they will just lose their form, the pitch, very easily. It won't take much to damage these. So once that gap closes ever so slightly, feel a bit of resistance, you stop there, and that's good enough. Because it's overlapped, no light will get in. This new piece is a little bit different as well. I've taken off the edges here so that there's less chance of jabbing yourself in the face. After saying all that, I received some new acrylic pieces which were a little bigger than what I had ordered, and while assembling a second kit, 2 pieces became wedged apart when slotting in the acrylic, and the mounting holes I was worried about lost their threads, becoming unable to tighten. I felt that it was kind of my fault, as when you get stuff cut, there's always a working tolerance, plus or minus a few millimeters, and I hadn't specified that I needed them quite accurate or just shy off the measurements requested. I approached the supplier with, I'm not asking for a refund, but if I reorder, I need to know if this can be made exactly as specified, as the parts need to fit into custom made slots which have only factored 1mm tolerances. Do you have access to a laser cutter for cutting plastic by any chance? Please advise and best wishes. And they replied, kind sir, sorry about that. When you are ready to reorder, we will laser cut at the same cost and send a couple of spares. Kind regards. But this made me think, well, I've got 2 sets of acrylic pieces that are now defunct, unless I design version 4, which really should be a parametric version. So, this is version 4, the parametric version, which I didn't plan to make, but I should have. Parametric models contain key parameters such as the height and width of the acrylic pieces in my case, as references which would allow me to interactively make changes to the design by simply changing a dimension, which can automatically update the 3D model. It is a great way of making efficient and easily adjustable designs, and in this case reduce waste. It is cobbled together, which works when making the minor variations based on the measured dimensions of the acrylic pieces, but it is not perfect. Designing like this can take days, to be honest, because of the knock-on effect changing one measurement has on another part of the design, and the amount of testing that must be done. For example, I can't change the width of the mirrored pieces to make them as big as a house. As you can see, the model breaks. But eventually I achieved something that more or less worked. And while I was at it, I took the opportunity to make some changes, including simplifying the side pieces, so the recess and slots were at the same depth. This actually was essential for converting to a parametric design, as it simplified the mathematical relationship between the parts. I also adjusted the design of the main body top piece so that it could be printed vertically in the same way as the main body rear piece, thus improving the mounting thread resolution. And while I was at it, I made a viewfinder cap as well. It occurred to me that if dust got inside, cleaning would be an issue. It may be tempting to dismantle the model to access the interior, but that should really be avoided to prolong the life expectancy of the 3D model threads. I'm now setting up the camera Lucida to draw with, starting with the arm which will hold the drawing tool clamped to a table. I'm using a Manfrotto Magic Arm, but you can also use cheaper lighting clamp stands like the one on screen. But the Magic Arm is much easier to use and fix into position. I locate the arm so the camera Lucida overlooks where I will place a piece of paper and is pointing towards my subject, which in this case is a romantic wax peanut candle. I attach the phone clamp and tripod plate to the camera Lucida and then clip the assembly to the arm. I also use a beautifying ring light to illuminate the subject, which is important because the strong contrasting light will make the object visible in the viewfinder. Of course, I should also make sure I am comfortable looking through the device and while drawing so I don't do my back in. I can then draw marks on the paper to outline the subject within the field of vision available to me, and with a fair bit of accuracy capture the object but also its environment. When correctly done, the foreshortening of the room or objects creates a sense of realistic perspective. Once those are documented, I can ignore the camera Lucida and draw what I see, making marks to populate the page with the subject. This drawing probably didn't come out as well as it could have, but later that evening when the light levels had dropped, I drew some toys. These conditions helped me to see the subject clearer in the reflection, and I didn't have to wave my hand under the Lucida to create shadow with which to see more detail. These drawings of the toy sitting on mugs seem much more expressive and free-flowing, and they don't automatically shout out, "I've been traced, he's cheating, all lies." I also tried replacing the mirror in clear acrylic with a front-facing mirror and a two-way see-through mirror, which actually further improved the image quality and removed the double image created from the previous setup. That said, I could see less of the paper, so I'm not sure which is actually more helpful. Anyway, I think this video has come to a natural end. I hope you enjoyed peering into the process of how I design my own camera Lucida. I'll link to all the interesting sources which helped me make this video on my website, and if you would like to make one yourself, the design will be available to download. I'll write some directions in the comments or description. And that leaves me with the final thing to say, which is thanks again for watching, and don't forget to sacrifice a thumb to the algorithm gods, a catchphrase which is losing meaning in each video as I'm using fewer dangerous hand tools with which to sacrifice my own thumbs.